Okay, so separating the variables is not the only method on finding the general or particular solutions of the first order differential equations. There are in fact three: separating the variables, an integrating factor, and then there's something else as well, which I've completely forgotten on. But integrating factors is more or less the same method. The two of the methods are essentially the same method, so it doesn't really matter. So what we're going to find is that this is an example here. So the general solution of, find the general solution of x cubed dy by dx plus 3x squared y equals sine x. You're probably, So you're probably thinking, what the hell? What the heck? How are you going to do this? You can't use, there's no way that you can use separating the variables. That's why we have integrating factors for. Okay, so what I'm just going to teach you for a second, this is a reminder on implicit differentiation. So if you notice, what is the derivative of y? The derivative of, so d by dx of y is equal to dy by dx. Yes? That is the first derivative of y. D by dx, x cubed, is equal to 3x squared. Okay. What do I do with these? For the smart people out there, you should have recognized that the derivative of x cubed is right here, 3x squared. So x cubed and 3x squared. Also considering that the derivative of y is equal to dy by dx. So what's going on here? Have we got, is this a product rule? Is this a implicit product? Well, I am definitely correct on that one. So let me just show you for a second. So if you differentiate x cubed y, for example, what you're going to get is x cubed. You're going to keep x cubed as it is. So you set u to x cubed and v to y. So it's going to be u dv by dx. So x cubed dy by dx plus v du by dx, rather than that, equals sine x. So what we can do, we can actually, since d dx, x cubed to the power, x cubed y, is a product of this, we can actually turn this, essentially this is the reverse products implicit rule, essentially. So you're reversing the product rule and turning it into this. So what we can say is that d dx x cubed y is equal to sine x. That's what we can say, genuinely. So now if we have, because one, I've already explained, but for those of you that still don't get it, I think you need to go back to implicit differentiation and just look this over, because this isn't an easy concept to figure out unless you've already done, say, A-level maths or calculus 1 or 2 in the US, it doesn't matter. But x cubed y, the product of this is equal to x cubed dy by dx plus 3x squared y. So now what we do, we integrate both sides with respect to x. We don't need to put respect to x on this side because we already have a d dx. So what this does, that cancels and we're just left with x cubed y is equal to minus cos x plus c. That is what we're left with. Okay? So, what's next? just divide by x cubed. So we have minus 1 x cubed cos x plus c over x cubed. And that is our general solution of the differential equation. Sorry. So let me just go over what had just happened. So what we have, we're trying to find the general solution of x cubed dy by dx plus 3x squared y equals sine x. So realizing that u and v, so u and v, you basically combine them together and create d dx x cubed y, where d dx just means the derivative of x cubed y. That's what it means, just the derivative. And then obviously this derivative creates this equation on the left hand side. And then now what we've done is that the derivative of x cubed y, if you integrate the derivative, it just gives the original uv function. And that's it. That's literally just how it is. And then you rearrange for y. It's not difficult at all. It really isn't. So, now we're going to, this is the second method. So eventually reverse product implicit. Now what we're going to do, we're going to move on to a third method. And this one isn't particularly easy. This one is the integrating factor. This isn't an integrating factor. This is just identifying what u and v is, combine them together, and then whatnot. I've already explained it so many times, you're probably fed up of it. So let's move on. Okay, so find the general solution of. So find the general solution of the differential equation of dy by dx minus 4y equals e to the x. Okay, so the problem is that we have no product anymore. There is no definitive way that we can find the differential equation. We can't, how the hell can we get y straight from just this, including this e to the x right here? It's actually easier than you think. So, you can solve a first order differential equation of the form dy by dx plus v plus p, px, y, qx. So what we're going to do is, this, you have to look carefully here. So, the equation here, to find the integrating factor. So the integrating factor is always e to the power of minus 4x. Yes. Sorry, it's e to the power of minus 4 with respect to dx. Sorry, let me start again. So, the integrating factor is whatever's on this side, and you times it, so it's e to the power of the integration of minus 4 with respect to x. This might seem like a really weird concept, but in time, it'll come. So, I'm just going to go through more examples so you just fully understand what's going on. So, e to the power of the integration of minus 4x. So what this is pretty much just e to the power of minus 4x. We don't put a plus c, we just don't, because there's absolutely no point in doing so. Okay, so what we've got, so this is now our integrating factor. So what we're going to do, we are going to times everything in this differential equation. So now we have e to the power of minus 4x dy times dy by dx minus 4 e to the minus 4xy equals e to the x times e to the minus 4x, which then becomes just e to the minus 3x. Okay? So, we now have our integrating factor here. So when you differentiate e to the minus 4x, you have minus 4 e to the 4x. And obviously your v product is y. So now we're going to have the differential of e to the minus 4x times y is equal to e to the minus 3x. Yeah? Okay. That is literally what we had done in the last example. That is what we've done. So all we've done is just added this integrating factor. And it's pretty simple. It's not too difficult whatsoever. So now you integrate both sides. That's respect to dx. The derivatives cancel. End up with e to the 4x times y is equal to minus a third e to the minus 3x plus c. That is what you end up with so far. Okay. So, what we're going to do, we are going to divide by e to the power of 4x. So when we do that, we end up with y is equal to a third e... Oh, sorry. Minus a third e to the x plus c e to the 4x, because that's a reciprocal. Yeah, that's what we get. And that is our general solution. So let me just go through it one more time. So we're finding the general solution of dy by dx minus 4y equals e to the x. We need an integrating factor. So the integrating factor is whatever is with the y. So it's minus 4. And that is integrated by e to the power of the integration of whatever is in the y term. Yeah? Okay. And then obviously we just do exactly with the same thing. You find your product, you find your implicit, and then you integrate both sides, they cancel, and then just rearrange for y. And now you found your general solution. Yeah? Excellent. So we're just going to move on to another example. Okay. General solution of cos x dy by dx plus 2y sin x equals cos 4x. Okay, so what we are going to do here is we are going to divide. Okay, so let's just start where we think. Let's just start from where we can think we can go. So we can't immediately just do the integration factor. The only way that you can actually do the integrating factor is if a dy by dx is on its own. So what we need to do here is that we need to divide by cos x all the way through. Okay? So divide by cos x. So we end up with dy by dx plus sine over cos. So 2 sine over cos is equal to 2 tan. That's just the symbols I give it. Dy by dx plus 2y tan x is equal to cos to the power of 3x. Okay? So our integrating factor is now going to be 2 tan x. So I'm just going to put IF So integrating factor is e to the power of the integration of, we're going to factor the 2 out, tan x dx. That's what we're going to be doing, okay? So when we integrate tan x, we are going to end up with 2 ln sec x. Oh, sorry. What about that? Is that correct? Pretty sure. Yeah. Sorry. So it's going to be 2 ln sec x, which then using the power law from logs, e to the power of ln sec squared x, and because e to the power of ln cancels, and there's no 2 in front of it, that cancels, and now we're just left with sec squared x. So sec x squared is what we're going to be, sec x squared is what we're going to be using when we're going to times everything together. So when we times sec squared x by everything, we get sec squared x times dy by dx plus 2y tan x sec squared x equals cos x sec squared x. Okay? That is what we're going to get. So you times everything by your integrating factor once you've manipulated it into an e to the ln sec squared x. Sorry about that. And then it just leaves with sec squared x, okay? There's one thing you might have noticed here. Sec squared x is actually 1 over cos squared. Those cancel. Did you know that? Because I would write it somewhere, but essentially, because this is times 1 over cos squared x, the 3 cancels and you're left with cos x, and that's literally it. It's very clever. It's really clever how all this stuff works. It really is. So essentially now, when you differentiate sec squared x, you will end up with 2 tan x sec squared x still. So now what we're going to be doing is setting your derivative up. So your derivatives are going to be y sec squared x. So sec x is your u, y is always going to be your v. It's equal to cos x. Integrate both sides. They cancel. That turns into sine x plus c. That turns into y sec squared x. So now y is equal to sine x over 1 over cos squared x plus c. Sorry. I'm going to just name this a different. I'm going to call this k. So k cos squared x. That's what we're going to be doing. Cos squared, 1 over cos squared is equal to sec squared. Just a reminder. And then just rearrange, so you end up with sine x cos squared x plus k cos squared x. And if you really want to, you can factorize this. So cos squared x is equal to sine x plus k. Yeah? And that's literally it. That is the general solution. So y equals, and that is a general solution. I'm going to show you very quickly how you work out the particular solutions to this. So you'll be given in the original equation when when y equals 2, x equals 0. So what do you actually do with this? first off, when you're being asked, find the particular solution, you have to find the general solution first. So you have to get all the way down to this point here. So when y equals 2, x equals 0. So when we do this, 2 is equal to cos squared x is, cos 0 is 1. So it's going to be 1, 0 plus k. So k is going to be 2. That's pretty simple. And your particular solution, oh, sorry, I don't know if you can see. So your particular solution, this is essentially the solution that determines, your boundaries. This is a particular boundary. So your particular solution is equal to y cos squared x sine x plus 2. That is the required particular solution. That is what you usually get. This is pretty much a box standard differential question, essentially. So I'm just going to give you some exercises, and then we'll literally finish up on first order differential equations. The next time I'll come back to first order is when we do reproducible equations, where you use a transformation to turn into differential equations. Use a transformation to work out the solution, and then you essentially convert it back. Okay? All right.